Hey guys, so today we're going to do A-level Maths Pure Mathematics 1 for paper code 9707. In this video, we're going to do everything that comes in functions. So that includes transformations, inverse function, composite function, finding the domain and range. So let's start with this video and see what kind of questions you can get for functions in A-level Maths. So as you can see, I've collected questions from 2018 to 2025. In this video, I'll try to incorporate a question from each year. We're going to focus on the different type of questions that can come for each thing. Like, for example, what kind of question you get for inverse, then for domain, then the composite, and then the transformation of functions. So I'll make sure that we focus on the different type of questions that are coming, not like the same thing that appears each time. So in this one, it says the function f and g are defined by f of x equals to root x for x greater than equal to 0, and g of x is 3 root x plus 2 minus 5 for x, minus 5 for x greater than equal to negative 2. We have to describe fully a sequence of transformations which transforms the graph of y equals to f of x to the graph of y equals to g of x. You should make clear the order in which the transformations are applied. So first, f of x equals to root of x is becoming f of x equals to 3 root of x. We're multiplying the function by a scale factor of 3. So the graph So as you can see, the graph is stretching by a scale factor of 3. Then we add 2 to x. So now that means we're moving 2 units to the left side, which is a horizontal transformation. Whenever you add something directly to x, that means you're moving that units to the left side. If you subtract something directly from x, you're moving that units to the right-hand side. And then lastly, we are subtracting 5, which means we're shifting the graph 5 units down. So that is the correct order for your transformation from f of x to g of x. When the diagram shows a graph of y equals to g of x, on the diagram sketch the graph of y equals to g inverse of x together with any relevant mirror line. Mirror line is going to be your y equals to x. So the inverse function is going to be reflection in the mirror line. So if I roughly sketch it, it's going to look like this. This is going to be your g inverse of x. Then find an expression for g inverse of x. So g of x is basically 3 root of x plus 2 minus 5. To find the inverse, we first put the function equal to y. So y equals to 3 root of x plus 2 minus 5. First, we take minus 5 to the other side. So it becomes y plus 5 equals to 3 root of x plus 2. Then we divide y plus 5 by 3. And that equals to root of x plus 2. Then we will square both sides to get rid of the root. So that's going to be y plus 5 whole square divided by 9 equals to x plus 2. And then lastly, we subtract 2. So your inverse function is x plus 5 whole square over 9, and then minus 2. That is your g inverse of x expression. Then state the range of g inverse. So if we look at the original function, g of x had the domain of x greater than equal to negative 2. So for these type of questions, you need to remember that if they've given us the original function and its domain and range, we can use that to find the domain and range of the inverse. So whatever is the, let me just write that over here, domain and range of the original function, that becomes the range of the inverse, and range is the domain. So we know x equals to greater than -2 is your domain. So that becomes the range of the inverse. So g inverse of x is going to be greater than equal to -2. That is your range. Once again, we swap the domain and range for the inverse and the original function. Then we have another function h of x, which is given as x minus 2 for x greater than equal to 0. We have to find the value of g inverse of h of 4. So let's first find h of 4. That's going to be 4 minus 2, which is 2. Then you put in the expression for g inverse of x. G inverse of x is x plus 5 whole square over 9 minus 2. So the domain is now 2. That's going to be 2 plus 5 squared over 9 minus 2, which is 7 square, 49 over 9 minus 2. That's going to give us 31 over 9. That is your value. Then explain why the composite function here g of inverse cannot be formed. So if you look at h of x, so as you can see for h inverse of x, the domain is x is greater than equal to 0, whereas for the range of g inverse of x, the domain has to be greater than equal to -2. And when you put g inverse of x in the h of x function, it's basically the range of g inverse of x. So if that is greater than equal to -2, whereas for h of x, the domain is supposed to be x is greater than equal to 0. Because of that, we cannot have the composite function. Because once again, g inverse of x is greater than equal to -2. We're making g inverse of x your domain of h inverse of x. So if this is greater than equal to -2, whereas h of x is supposed to be greater than equal to 0, it's not even overlapping. Like it's x greater than equal to 0 is on the other side, and x greater than equal to -2 is on the other side. So because of that, the composite function cannot exist. Whereas h inverse of x is greater than equal to 0. Hence, the composite doesn't exist. Then the diagram shows the graph with equations y equals to f of x and y equals to g of x. Describe fully a sequence of two transformations which transform the graph of y equals to f of x to the graph of y equals to g of x. Make clear the order in which the transformation should be applied. So if we compare the graphs, we can see that the graph has stretched, which means it has been multiplied by a scale factor, and it has shifted down. So if we notice, the graph has been stretched by a scale factor of 2. So if we pick 2 points on the graph, this one and this one. So it's 3, 3. And this has been transformed to 3 and -8. So if we compare the y values, we know that the scale factor is 2. We need to figure out the vertical translation. So 3 times 2 minus something equals to -8. 3 times 2 is 6. And -8 minus 6 is going to be -14. So that means the graph is shifting 14 units down. So first we times the graph by a scale factor of 2, and then we shift the graph 14 units down. So multiply the y values by a scale factor of 2. Then the graph shifts 14 units down by a translation vector of 0, -14. So we have stretching happening first, and then we have translation. That is your answer. Then it says express x squared plus 4x plus 2 in the form of x plus a whole square plus b, where a and b are integers. So in this, we have to use completing square form to convert it in that format. So x squared plus 4x plus 2. Complete square form is a squared plus 2ab plus b squared. We have our a squared and 2ab. We have to find our b square value. So 4x equals to 2xb because a is x. 4x divided by 2x is b, and that's going to give us 2. So x squared plus 4x plus 2 square because plus b square. And then we do minus 2 square plus 2. The reason why we're doing minus 2 square is because plus 2 square is a new term that we introduced in the equation. So we have to subtract it as well. So complete square would be x plus 2 whole square. The minus 2 square becomes minus 4, which comes outside the bracket. And x plus 2 squared minus 2 is your answer. So a is 2 and b is -2. Then we have two functions. F of x is x squared plus 4x plus 2 for x is less than equal to -2. And g of x is negative x minus 4 for x is greater than equal to -2. We have to find an expression for f inverse of x. So for f inverse of x, whenever we have a quadratic function and we want to find its inverse, we convert it into completing square form first. So if I'm not wrong, it's the same one. Yeah. So we just use the completing square form from part A, which is x plus 2 whole square minus 2. Now we use this equation to find the inverse. So y equals to x plus 2 whole square minus 2. Y plus 2 equals to x plus 2 whole square. We're isolating x step by step. Then we take the square root. So that's x plus 2. Then y plus 2 minus 2 equals to x. We have plus minus over here. Now it's saying for f of x is less than equal to 2, which means this is going to be the range of the inverse, less than equal to -2. So if the range of the inverse is less than equal to -2, which means we will choose the negative root, not the positive one. So f inverse of x is negative root of x plus 2 minus 2. That is the expression for the inverse. Then find an expression for g f of inverse x. So you first find the composite function for g of x and then find the inverse of that. So g of x is given as minus x minus 4 and x squared plus 4x plus 2. Minus x minus 4 and x squared plus 4x plus 2. So we're substituting f of x and g of x first. So g f of x is going to be negative. So g f of x is going to be negative x squared plus 4x plus 2 minus 4, which is negative x squared minus 4x minus 2 minus 4, negative x squared minus 4x minus 6. So now to find the inverse of g of fx, we have to find the completing square form of this. So first we take -1 common from the entire equation. That's going to be x squared plus 4x plus 6 over here. -1 bracket x squared plus 4x plus 2 squared minus 2 squared plus 6. So that's x plus 2 whole squared minus 4 plus 6. Multiply the negative sign, so negative x plus 2 whole squared plus 4 minus 6 which is going to give us minus 2 over here. Now, we're going to find the inverse of this. So y equals to negative x plus 2 whole square minus 2. Y plus 2 equals to negative x plus 2 whole square. Divide both sides by negative 1. So negative y minus 2 equals to x plus 2 whole square. Square root both sides. So plus minus negative y minus 2 equals to x plus 2. Plus minus negative y minus 2 equals to x. So as you can see for g of x, the domain is x is greater than equal to negative 2. So for the range, it's going to be greater than equal to negative 2, which means we will pick the negative 1 again. So g f of inverse of x is going to be negative root of x minus 2 minus 2. That is the inverse of this composite function. And the next question says that the function f is defined by f of x equals to x squared plus 4ax plus a for x contains all real numbers where a is a constant. The function g is such that g inverse of x is cube root of 2x minus 4 for x contains all real numbers. Given that the range of f of x is greater than equal to negative 33, we have to find the possible values of a. So there are different ways of approaching this question. You can either use a discriminant or you can use completing square form to figure out what the value of a is. If you use the completing square form, first we need to convert f of x into completing square form. So we have x squared plus 4ax plus a. We know complete square form is a squared plus 2ab plus b squared. So our a squared is x squared, 2ab is 4ax, and we have to figure out our b squared. So x squared plus 4ax plus, if we put 4ax equals to 2xb, we can easily see that b equals to 2a. So plus 2a whole square minus 2a whole square and then plus a comes as it is. So the complete square is this part over here. That means it's going to be x plus 2a whole square minus 4a square plus a. Now, since the question says that the range of f is f of x is greater than equal to negative 33, which means this part is equal to negative 33. Why? Because the smallest value of the function, the smallest value of y is negative 33. And this also denotes the smallest value of the function, like the minimum maximum value. Since this is a minimum curve, so this is the minimum value of y. So that means negative 4a squared plus a equals to negative 33. Negative 4a squared plus a plus 33 equals to 0. We have a quadratic equation in terms of a, so let's solve that to find the possible values of a. 4a squared minus a minus 33. You can use the quadratic formula splitting the middle term. If we use splitting the middle term, 33 times 4 is 132. Factors of 132 are 12 times 11. So if we use 12 times 11 over here to replace a, we can say that 4a squared minus 12a plus 11a minus 33 equals to 0. In 4a squared and 12a, we have 4a common. So a minus 3 comes in the bracket. Between 11a and 33, we have 11 common. So a minus 3 again comes in the bracket. So that's going to be a minus 3 times 4a plus 11. So based on this, a is 3 and a is negative 11 over 4. That is your answer. Then given that f of g of 0 equals to 96, find the value of a. So the questions have given us the inverse of g of x. So let's use that to find the expression for g of x and then use that to figure out the value of a for the given thing. So G inverse of x is cube root of 2x minus 4. Y is going to be equal to cube root of 2x minus 4. We will cube both sides. So that's going to be y cube equals to 2x minus 4. Add 4 to the left-hand side. So that's going to be y cube plus 4 equals to 2x. Y cube plus 4 divided by 2 is x, which means g of x is going to be x cube plus 4 over 2. Now g of 0 is going to be 0 cube plus 4 over 2, which is 2. G of 0 is the same as g of 2, which is 2 cube plus 4 over 2, which is going to be 6. F of g of 0 is f of 6, and that's going to be x squared plus 4x plus a. Substitute the value of x as 6 because that's the new domain. That's going to give us 36 plus 24a plus a. So that's going to be 36 plus 25a. So this is equal to 96. 96 minus 36 over 25 equals to a. That's going to be 60 over 25. And that's 12 out of 5. That is the value of a. Then it says the function f is defined by f of x equals to 2 over x squared plus 4 for x is less than 0. The diagram shows the graph of y equals to f of x. On this diagram, sketch the graph of y equals to f inverse of x. Show any relevant mirror lines. So your mirror line is going to be your y equals to x line. And for the graph, it's going to look something like this. Because it's a reflection in the y equals to x line. So you reflected, this graph comes over here in the opposite quadrant. Then find an expression for f inverse of x. So y equals to 2 over x squared plus 4. Let's make x the subject. Y minus 4 equals to 2 over x squared. X squared equals to 2 over y minus 4. We swapped y minus 4 with x squared. And then we take the square root on both sides because we want an equation for x, not x squared. So that's plus minus 2 over y minus 4 square rooted. Now, f of x is less than 0, which means we look at the values for negative square root. So f inverse x is going to be a negative root of 2 over x minus 4. If it was greater than 0, we would look at the positive root. Then solve the equation f of x equals to 4 minus 5. So 4 minus 5 equals to 2 over x squared plus 4. So that's going to be 4.5 minus 4 equals to 2 over x squared. X would be 2 over 0.5 being square rooted, and that is going to give us root of 4. Since they want the negative value because f of x is less than 0, so x is going to be negative 2. That is your answer. Explain why the equation f inverse of x equals to f of x has no solution. The reason why both of them have no solution because if you notice, f inverse of x is a negative function, whereas f of x is a positive function. So if they're in opposite quadrants, as you can see over here, there is no intersection. And since there is no intersection, there will be no solution. So you'll just simply say f inverse of x is negative, while f of x is positive. Hence, there is no intersection of the two functions. That's your answer. Then it says the function f is defined as follows. F of x equals to root of x minus 1 for x is greater than 1. Find its inverse. Y equals to root of x minus 1. Y plus 1 equals to root of x. Square both sides to get rid of the root. So that's going to be y plus 1 whole square equals to x, which means f inverse x is going to be x plus 1 whole square. That is your expression for the inverse of the function. Then the diagram shows the graph of y equals to g of x, where g of x equals to 1 over x squared plus 2 for x contains all real numbers. State the range of g and explain whether g inverse exists or not. So for the range of g, it's going to be all real numbers. To figure out the range of g, we need to look at the function. The function is rational because it's 1 over x squared plus 2. So since the denominator has a higher degree of power compared to the numerator, which means the horizontal asymptote is going to be y equals to 0. So horizontal asymptote is y equals to 0. And as you can see, the graph doesn't intersect y equals to 0 like the x-axis, it's above it. Now for the maximum point over here, we put x equals to 0. When you put x equals to 0, we get y equals to 1 over 0 square plus 2, which is 1 over 2. So this is your maximum value of the graph. The graph cannot be greater than this value, which means your range of gx is going to be gx is less than equal to 1 over 2, but greater than 0. This is your range of g of x. Then we need to explain whether g inverse of x exists or not. G inverse of x is not going to exist because it's not going to be a one-to-one function. Because if we try to find the inverse of that, y equals to 1 over x squared plus 2. X squared plus 2 equals to 1 over y. That's going to be x squared equals to 1 over y minus 2. And x equals to root of 1 over y minus 2. It's going to be a square root. So that's going to be in a different position. And in that position, it's, I think, going to look something like this. And as you can see, it's not going to be a one-to-one function because for the same value of x, we're going to get different values of y, not one value of y. Hence, g inverse of x will not exist. So it is not going to be a one-to-one function. That is your answer. Then we have another function, h of x equals to 1 over x squared plus 2 for x is greater than or equal to 0. Solve the equation h of f of x equals to f of 25 over 16, giving the answer in the form of a plus b root c, where a, b, and c are integers. So f of 25 over 16 is going to be root of 25 over 16 minus 1, which is 5 over 4 minus 1, and that's 1 over 4. Then h of f of x is going to be 1 over root of x minus 1 whole square plus 2. Now, since both of these are equal to each other, so 1 over 4 equals to 1 over root of x minus 1 whole square plus 2. Root of x minus 1 whole square plus 2 equals to 4. Root of x minus 1 whole square equals to 4 minus 2. That's going to be 2. Then we square root both sides, so that's going to be root of x minus 1 equals to root 2, plus minus. So root of x equals to plus minus root 2 minus 1. So then we will square both sides and have to put a condition for x. X has to be greater than or equal to 0. So we negate the negative root. That's root x equals 2 plus minus root 2 plus 1. Since the value of x for h of x is greater than or equal to 0, so we only pick the positive root. So it's going to be root of x equals to root 2 plus 1. Then we square both sides. So that's going to be x equals to root 2 plus 1 whole square. Now we expand the bracket. Root 2 squared plus 2 times root 2 times 1 plus 1 squared, which is 2 plus 2 root 2 plus 1. And that's 3 plus 2 root 2. That is the value of x. Then says in the diagram, the graph with the equation y equals to f of x is shown with solid lines, and the graph with the equation y equals to g of x is shown with broken lines. Describe fully a single sequence of 3 transformations or transforms, which transforms the graph of y equals to f of x to the graph of y equals to g of x. So we're going from f of x to g of x. So if you look at the graphs, there is some vertical translation. And we can see that there's a change in the direction because this elongated line is now this one and this stretched one is over here, which means there's some reflection and then there's some stretching happening as well using a scale factor. So we're going from y equals to f of x to y equals to g of x. So let's first figure out what is the sequence of these transformations. So let's begin with picking 2 corresponding points. So we can pick this point and we can pick this point. These are 2 corresponding points. So 1 is going to negative 2 and 2. Since the x coordinate is becoming negative, which means it's a reflection in the y-axis. So reflection in the y-axis. So when you reflect this in the y-axis, that would give us negative 1 and 1. Now, negative 1 is becoming negative 2, which means each x value is being multiplied by 2. So now this is scale factor of 2. Scale factor of... Now when we reflect this in the y-axis, it should come over here firstly. So from 1, it goes to negative 1 and 1. So it's going to be translation by the vector negative 1, 0. Now from negative 1 to 1, it's now at negative 2 and 1. Now the third transformation that's happening is that 1 is becoming 2, which means the graph was right now over here. Now this is the point where it's going to be. So now this is becoming this, so we can see that all of the values are changing. So now if we compare the y values, this value over here, which is at 1, now it's going at 2, okay? And this value which is at 3 is going to go at 6, which means the y values are getting multiplied by 2. So now to go from negative 2, 1 to negative 2 and 2, it's a stretch by a scale factor of 2 parallel to y. So we start with the reflection in the y-axis. Then it's a transition by the vector of negative 1, 0 because you shift the graph 1 unit towards the left-hand side. And then it's being stretched by scale factor of 2 vertically, like parallel to y. So this is your correct sequence for the 3 transformations that are happening in this question. Then find an expression for g of x in the form of af times bx plus c, where a, b, and c are integers. So completing square form, basically. So we're going to use the transformations in this case. So we know that it's stretching by a scale factor of 2, which means there's going to be a 2 outside. So 2 f of, then x is being reflected in the y-axis. X is going to be negative x. So since we are translating by a vector of -1, 0, so it's going to be -1 over here. So this is your expression for g of x based on the given transformations. Then it says the function f is defined by f of x equals to 2x plus 1 over 2x minus 1 for x is less than 1 over 2. State the value of f of -1. So we just put x equals to -1 in the domain. So that's going to 2 times -1 plus 1 over 2 times -1, 2 times -1 minus 1, which is -2 plus 1 over -2 minus 1. That's -1 over -3, which is 1 over 3. That's your answer. Then the diagram shows the graph of y equals to f of x. Sketch the graph of y equals to f inverse of x on this diagram. Show any relevant mirror line. So this will be reflecting the y equals to x line. So let's draw that first. This is your y equals to x line. So whatever is your coordinate, you're going to swap that. So this is basically -4 and 0.9. So now it's going to be 0.9 and -4. So -4 is 0.9. So that's going to come over here. Then this one, -3 and 0.8, I guess. So now -3 and 0.8. So that's going to be somewhere over here. -2 and 0.6. So somewhere, so it's basically going to go like this. -1, something over here. Then it's going to cross at 0, -1. So now it's going to be -1, 0. So it's going to be something like this. This is your inverse graph. Obviously, it's a little rough because I'm drawing this freehand over here, but you'll draw this more accurately when you do it on the paper. Then find an expression for f inverse of x and state the domain of the function f inverse. So we have f(x) equals to 2x plus 1 over 2x minus 1. So y equals to 2x plus 1 over 2x minus 1. Cross multiply. So y bracket 2x minus 1 equals to 2x plus 1. Expand the bracket. 2xy minus y equals to 2x plus 1. Collect the terms with x on one side. So 2xy minus 2x equals to 1 plus y. Take x common, so 2y minus 2 equals to 1 plus y. So that's going to be x equals to 1 plus y over 2y minus 2. So f inverse x is going to be 1 plus x over 2x minus 2. Now for the domain, if we go to the first part, it says x is less than 1 over 2 for f of x. So if x is less than 1 over 2, over here, if we see the domain restriction is going to be the denominator. You put the denominator equal to 0. So x is going to be 2 out of 2, which is 1. X cannot be equal to 1. So if you look at the graph, it's less than x equals to 1, but not greater than, which means our domain is going to be x is less than 1. That's your domain, and your inverse function is 1 plus x over 2x minus 2. That's your answer. Then function g is defined by g of x equals to 3x plus 2 for x contains all real numbers. Solve the equation f of x equals to g of f of 1 over 4. So f of x was 2x plus 1 over 2x minus 1. So g of 2 times 1 over 4 plus 1 over 2 times 1 over 4 minus 1. So that's going to be 1 over 2 plus 1 over 1 over 2 minus 1, which is going to give us 2x plus 1 over here, 2x minus 1. So 2x plus 1 over 2x minus 1 equals to g of -3. So now 2x plus 1 over 2x minus 1 equals to 3 times negative 3 plus 2. 2x plus 1 over 2x minus 1 equals to negative 9 plus 2, which is going to give us negative 7. Cross multiply, and then we find the value of x. So that's 2x plus 1 equals to negative 14x plus 7. Collect the like terms on each side. 2x plus 14x equals to 7 minus 1. So that's 16x equals to 6. X equals to 6 divided by 16, which is going to be 3 out of 8. That is your value of x. And the next question says that a function f is defined by f of x equals to x squared minus 2x plus 5, for x contains all real numbers, and a sequence of transformations applied in the following order to the graph of y equals to f of x, to give the graph of y equals to g of x. First, we stretch parallel to the x-axis with scale factor 1 over 2, which means the x values are changing. Then we reflect on the y-axis. Again, the x values are changing. Then stretch parallel to the y-axis with scale factor of 3. Now the y values are changing. Find g of x, giving your answer in the form of ax squared plus bx plus c, where a, b, and c are constants. So in the first step, stretching parallel to the x-axis with scale factor 1 over 2, which means it's going to be f of 2x. If the scale factor is 1 over 2, that means we're multiplying 2 with x. If the scale factor was 2, then you're dividing x by 2. So this is the first transformation. Then it's a reflection in the y-axis, which means x is becoming negative. So f of negative 2x. Then stretch parallel to the y-axis with scale factor of 3. So that's 3 times the function. So 3 times f of negative 2x. This is the order in which the transformations are happening. So first, we replace x with 2x. So that's going to be 2x whole squared minus 2 times 2x plus 5. Then we're replacing it with f of negative 2x, which means now it's going to be negative 2x whole squared minus 2 times negative 2x plus 5. And then we're multiplying the entire function by 3, which means it's going to be 3 bracket negative 2x whole squared minus 2 times negative 2x plus 5. This is the order of the transformations. Now we simplify this. 3 bracket 4x squared plus 4x plus 5. Multiply everything by 3. So that's 12x squared plus 12x plus 15. That is g of x in the form of ax squared plus bx plus c, where a, b, and c are constants. Then since the function f is defined as follows, f of x equals to x cubed x squared minus 4 over x squared plus 4 for x greater than 2. Find an expression for f inverse of x. So y equals to x squared minus 4 over x squared plus 4. So we cross multiply first. Y bracket x squared plus 4 equals to x squared minus 4. X squared y plus 4y equals to x squared minus 4. Collect the terms with x on one side. So x squared y minus x squared equals to negative 4y minus 4. Take x squared common. So y minus 1 goes in the bracket. X squared equals to negative 4y minus 4 over y minus 1. X equals to square root of 4y minus 4 over negative 4y minus 4 over y minus 1. Since x has to be greater than 2, which means we'll take the positive square root, not the negative one. So f inverse of x is going to be positive negative 4x minus 4 over x minus 1. Once again, since the domain is greater than 2, which means the range is going to be greater than 2. So that's going to be positive square root. So that's going to be positive square root, not negative square root. So this is your expression for f inverse of x. Then show that 1 minus 8 over x squared plus 4 can be expressed as x squared minus 4 over x squared plus 4, and hence state the range of f. So we have 1 minus 8 over x squared plus 4. So we make the denominator equal by multiplying 1 by x squared plus 4 and dividing it by x squared plus 4. So that's going to be x squared plus 4 minus 8 over x squared plus 4. So that's going to be x squared minus 4 over x squared plus 4. So we just prove that it's the same. Now for the range of f of x is x squared minus 4 over x squared plus 4. And for this, x is greater than 2. So we find the value of f of 2. That's going to be 2 squared minus 4 over 2 squared plus 4, which is 0 over 8, and that's 0. So we know x equals to 2 is not included in the domain, which means f of x equals to 0 will not be included in the range. So it has to be greater than or less than, depending on what the other value is. Now, we know that the inverse for f of x is root of negative 4x minus 4 over x minus 1. Whatever is the domain of f inverse x, that's going to be the range of f of x. As we know, we swap the domain and range. So over here, the restriction on the domain is going to be that x minus 1 cannot be equal to 0. Because in a rational function, your denominator isn't equal to 0. Because when you take x as the subject, x will not be equal to 1, because when we put x equals to 1 in the rational function, as it is in this case, the denominator becomes 0. And if the denominator is 0, it's going to be undefined, which means f of x cannot be equal to 1. So based on the values we have, your range of f of x is going to be less than 1, but greater than 0. That's your answer. Then it says, explain why the composite function f of f cannot be formed. F of x is x squared minus 4 over x squared plus 4. Now we know that the restriction for the domain is that x has to be greater than 2. And for the range, it has to be less than 1 but greater than 0. So to check if we can find the composite function, let's take a value of x that's greater than 2 and see if that helps us in finding the composite function. So f of 3, let's say, is going to be 3 squared minus 4 over 3 squared plus 4. That's 9 minus 4, which is 5, and 9 plus 4, which is 13. So if we do 5 divided by 13, that's 0.38. Now, if you put that in the function again, we know that x has to be greater than 2. Whereas over here, x is coming out to be 0.38, which is incorrect based on the given condition for the domain. So because of that, composite function is not possible. Possible because x has to be greater than 2. Whereas over here, x is equal to 0.38, because this 0.38 becomes the domain of f of x, because it's a composite function. If it was not a composite function, 0.38 would be the range, and that would be correct based on the given conditions. But since it's becoming the domain now, and the domain has to be greater than 2, so it's not possible. Then the next question says, the graph of y equals to f of x is transformed to the graph of y equals to 2 times f of x minus 1. Describe fully the two single transformations which have been combined to give the resulting transformation. So as you can see, we started off with y equals to f of x. Then it's y equals to 2 times f of x minus 1. So first we can say that there has been a translation by the vector 1, 0. When we're subtracting something from x, that means we're going that many units towards the right-hand side, which means the graph moves 1 unit towards the right-hand side. Then we're multiplying the function by 2. So stretch in the direction of y-axis or parallel to y-axis by the scale factor 2. That's your transformation. Then the curve y equals to sine 2x minus 5x is reflected in the y-axis and then stretched by scale factor 1 over 3 in the x direction. Write down the equation of the transform curve. So first we're reflecting in the y-axis, which means x is going to become negative. And then it's stretched by scale factor of 1 over 3. If it's stretched by scale factor of 1 over 3 and in the x direction, that means x is going to get multiplied by 3. So y is sine of 3 times negative 2x minus 5, 3 times negative x. That's going to be sine of negative 6x plus 15x. That is the equation of the transform curve. Then it says function f and g are both defined for x contains all real numbers are given by f of x equals to x squared minus 2x plus 5 and g of x equals to x squared plus 4x plus 30. By first expressing each of f of x and g of x in completing square form, express g of x in the form of f of x plus p plus q, where p and q are constants. So let's first convert f of x in completing square form. It's x squared minus 2x plus 5. That's going to be x squared minus 2 times x. B is going to be 1. So plus 1 squared minus 1 squared plus 5. That's going to be x minus 1 whole squared minus 1 plus 5, which is going to be x minus 1 squared plus 4. This is your complete square form from f of x. Then for g of x, it's x squared plus 4x plus 13. So x squared plus 2 times x times 2, which means it's going to be plus 2 squared minus 2 squared plus 13. That's going to be x plus 2 whole squared minus 4 plus 13, which is going to be plus 9. So now they want us to write g of x in the form of f of x plus p plus q. If we compare f of x with g of x, minus 1 becomes plus 2, which means we're adding 3 over here. And 4 becomes 9, which means we added 5. That means it's going to be f of x plus 3 plus 5. Because yeah, we add 3 over here to f of x and then we add 5 over here. So that is g of x in terms of f of x. Then describe fully the transformation which transforms the graph of y to f of x to the graph of y to g of x. So we can see that we're moving 3 units to the left horizontally and we're moving 5 units up. So the translation vector is going to be by vector negative 3 and 5. That is your transformation. This diagram shows graphs of the equations y equals to f of x and y equals to g of x. Describe fully a sequence of two transformations which transforms the curve y equals to f of x to y equals to g of x. So now if you look at the transformation, let's pick 2 points. So we pick this point and this point. We're going from f of x to g of x. So this point is 3 and 3 on y equals to f of x, and g of x is negative 3 and 6. So if we compare the points and the shape of the two graphs, we can see that the direction is exactly the same, which means there is no reflection. However, the graph has moved 6 units to the left-hand side. And then for the y value, This was 3, now it's 6, which shows that the graph has stretched by a scale factor of 2. Hence, the translation vector is going to be translation by a vector of -6, 0. That is a translation vector. And then the graph has stretched in the direction of the y-axis by a scale factor of 2. That is your answer. And with that, we're done with the questions for functions. This included inverse functions, composite functions, domain and range, and transformations of functions. If you have any questions or confusions, please leave a comment below and I'll help you out. And if you understood everything, please like and subscribe, share this video with your friends, and stay tuned for other topics for paper 1 because I'm going to post them step by step. All of the questions are going to be past paper based, and I'm going to attach the document link for the topical questions for each video that I make for each topic so that you can just download it and practice more for the given topics.